Hello guys, good morning. Today in this video we'll be talking about partial differential equations. Is everything all right? Okay, let's quickly take up this session. Actually my laptop charging is not working. I don't know how will you continue. Still, so let us start with the homework problem which I gave you on the last day. Have you solved it? So I gave you this problem. Solve the Laplace's equation. Subject to the boundary condition. Subjected to the boundary condition. What were the boundary conditions? U at 0y is equals to 0, U Ly to 0, U at x0 equals to 0, and U at xa is equals to sine n pi x by L. This was the given situation. So you can see the situation is like this. It is talking about a rectangular region which has length like this, which has a length, okay. So this is the scenario. We have x, y is 0, this is, let's say, L, and this is A. So this is the region R. Okay. So for this we can start with the solution. Everything all right, right? We can start with the solution of the Laplace equation. We have already derived it on the last class. So we know the solution of the 2D Laplace equation. We know the solution of the 2D Laplace equation. How it is given? U of xy is equals to x of x, y of y. Okay. So x of x, it was given by a cos lambda x plus b sin lambda x, and y was given by c1 e to the power lambda y plus c2 e to the power minus lambda. So this was the solution we derived for two-dimensional Laplace equation. Now let us try to utilize the boundary condition or initial condition. Let's say we are utilizing the boundary conditions to evaluate the unknown constants. So here 4 unknown constants are there: a, b, c1 and c2. So 4 boundary conditions will be sufficient to evaluate all of them. So the first boundary condition u0y is equals to 0. This means x at 0, y at y equals to 0. Y of y is a variable. So we can conclude from here that x at 0 is equals to 0. And this part is your x of x, and this part is your y of y. X of 0 equals to 0. If you put it here in this equation, we can write 0 is equals to a into cos 0 is 1 plus b into sin 0 is 0. So that gives you a is equals to. So this kind of treatment we have done several times. So this is the first boundary condition we have utilized. Let's go for the second boundary condition u ly equals to 0. So it directly corresponds to x of L, y of y equals to 0. Y of y is a variable, so x of L equals to 0. So utilize this. Now we have b equals to 0. So from here we can write x of x. This is your a cos lambda x. If that becomes 0, so we can say that 0 is equals to, sorry, this will a is 0. So what remains? B sin lambda x, that you have to write. B sin lambda x. So 0 is equals to B sin lambda L. So this can be written as sin lambda L is equals to 0. That is equals to sin n pi, and hence lambda is equals to n pi by L. Clear? So we can write x of x is equals to b sin lambda x, means n pi x by L. Okay. So two boundary conditions we have used. Let's go for the third one, that is u of x0 equals to 0. So u of x0 is equals to 0. It means x of x, y of 0 equals to 0. X of x is a variable, y of 0 will be equals to 0. Now y of y is equals to this. If you put 0, y equals to 0, it becomes c1 plus c2 equals to 0, right? This gives you c1 plus c2 equals to 0, means c1 is equals to, or in fact I should write c2 is equals to minus. If c2 is equals to minus c1, what does your y become? Y of y, you see, cn we can take common, e to the power lambda y minus e to the power minus lambda y. Okay. Now what we can do, we can divide by 2, multiply by 2. So it doesn't change anything. If we do this, this becomes the sine hyperbolic lambda y, and 2c1 sine hyperbolic lambda y. And hence you can write the solution, overall solution u of xy is equals to, you see, 2c1 into b. We have taken 2c1 into, let's write it bn. So 2c1 into bn. So this is another constant. So let's denote that constant for by kn. Sin n pi x by L from the x part, and this sine hyperbolic lambda y. So lambda is equals to n pi by L. So n pi y by L. You can see lambda is equals to n pi by L, so we have just put the value. So n is there. Now we need to specify the summation. N is equals to 1 to infinity. Now to get this solution, we need to find out this unknown constant Kn. So we can use the fourth condition. Fourth condition says u of xa is equals to sin n pi x by L. U of xa is equals to sin n pi x by L. Right? So therefore, you see, wherever you see x, you will put x, and wherever you see y, you will put a. So sin n pi x by L, this is equals to kn sin n pi x by L sin hyperbolic n pi y is equals to a by L. So sin n pi x by L is getting cancelled from both sides. That gives you kn is equals to 1 upon sin hyperbolic n pi a by L. Okay, and ultimately this gives you the solution u of xy. Now the unknown constants all have been evaluated. So 1 upon sin hyperbolic n pi a by L sin n pi x by L sin hyperbolic n pi a by L, sorry, n pi y by L. I hope this solution is clear. It's a very straightforward solution. If you have understood the previous parts very well, then this is nothing. So you will get questions in this form. If you ever get a question from this Laplace's equation, you can expect a question like this. Clear, Harry? Murli, Ajay, where are you guys? Okay, let's move on to this problem. So look at this problem. Find the temperature U of xt in a laterally insulated copper bar 80 centimeter long. If the initial temperature is 100 sin pi x by 80 degrees centigrade and the ends are kept at 0 degree centigrade, how long will it take for the maximum temperature in the bar to drop to 50 degrees centigrade? Physical data for copper: density, specific heat, thermal conductivity. Thermal conductivity is K, specific heat and density is given. Specific heat, let's say sigma, density is rho. So this is your one-dimensional heat equation. This problem is from one-dimensional heat equation. Look, there we used the term c square, right? C square is equals to, or a square, a or c, whatever you have used, A square is equals to K upon sigma rho 0.95 upon sigma is 0.092 times rho is 8 point. All of them are given in CJS unit, so it doesn't matter. We can directly put it. So if you evaluate this, you will get 1.158 centimeter square per second. So this value you did not know, so I have just given you A square. Other things you know, initial temperature is given 100 sin pi x by 80 degrees centigrade. What does it mean? In our mathematical language, if you are given the initial temperature, what does it mean? It means the initial temperature is given by 100 sin pi x by 80 degree centigrade. So if this represents the temperature, this represents the temperature at some point x at time t. Now, so if you consider, this is obviously a one-dimensional bar which we considered. So this bar is 80 centimeter long, and as usual the two ends are kept at 0 degree centigrade. What does it mean? Two ends are kept at 0 degree centigrade. What does it mean? It means that it is cooled. It is being cooled at the ends, right? It is being cooled at the ends. So before heat transfer, the initial temperature was given by this. What does it mean? The temperature is not constant throughout the bar. It is varying sinusoidally throughout the bar. The initial temperature is 100 sin pi x by 80. It means u of temperature at any x at time 0. This is the meaning, right? Do you understand this or not? So this is equals to sum over n is equals to 1 to infinity bn sin n pi x by 80. Can we write it? You see the exponential term had t dependency e to the power minus lambda n square into t. So t, if you put 0, so e to the power 0 is 1. So that is why you get this. This is equals to f of x, that is given to you 100 sin pi x 80. Did you understand this line? First tell me, then we'll go forward. Just check the one-dimensional heat equation, the way we solved one-dimensional heat equation, and let me know if you understand this one. Ajay, Harry. Check what solution we got. We got, I think, bn sin n pi x by l e to the power minus lambda n square into t. Okay. So if you compare the both sides, you see here only sin pi x by 80 is there. So what value of n is non-zero? We can say that pi x by 80 means n equals to 1. So n equals to 1 means b1. So we can write b1 is equals to 100. What will be b2? There is no such term like sin 2 pi x by 80 or sin 3 pi x by 80 or sin 4 pi x by 80. So b2, b3, before all of them, all of the coefficients will be 0. Now to write the solution we need lambda square, lambda b1, so n is equals to 1. So corresponding lambda is lambda 1, and in the exponential part we had lambda n square, so it is lambda 1 square. So what was the value? Cn pi by L. If you remember, what was lambda n? Lambda n is equals to Cn pi by L, right? So lambda 1 square will be c pi by L whole square, right? C pi by L whole square. This is equals to c square pi square by L square, where this c square is equals to k by sigma rho. We have written a square, so you can write c square. The c square value we have already evaluated, so we can directly put here 1.158 centimeter square per second. So if you put this value here, 1.158, this is the value of c square, into pi square, so around 9.870 divided by L square. L is equals to 80 centimeter log given to you, right? So we can write 80 square. So all of the units are used in CGS. Is equals to 0.00175 second inverse. That is u of xt exponential u of x0 is equals to summation of b and sin n by x. Yes, Harry. So another term was there, exponential something. So because t is equals to 0, so e to the power 0 is 1. So that is why that term is not. Okay. So what is the solution now? Lambda 1 square we have got. So the solution, therefore, the solution is given by u of xt. This is equals to 100 b1 sin pi x by 80. Only one term will be there in the summation, and e to the power minus lambda 1 square into t, so minus 0.001785 t. Okay. So this is what u of xt is equals to 100 sin pi x by 80 into this. It gives you the overall temperature distribution along the bar. Okay, this gives you the overall temperature distribution along the bar. So obviously the temperature is not uniform. The temperature is not constant. This end is kept at 0 degree centigrade. This end is kept at 0 degree centigrade. This is 0. This is L. So as you keep on varying x, your temperature is increasing, and it is following this pattern. So as you can see, as time goes on, the temperature exponentially falls. Okay. So here two parts are there. Try to understand it very carefully. Sin pi x by 80. So this gives you the temperature distribution around this rod. Okay, facial part. Now here time part is also there. So initially there will be a maximum temperature, and with time the temperature will fall down. Now as you can see, u of xt will be maximum at what value? You see the maximum temperature occurs at x is equals to how many centimeters? You see this total length of this rod is 80 centimeter. So can you tell me where the maximum temperature will occur? Is it here, or where? Can you tell me where maximum temperature will be there? This is a like u of xt, you read it like temperature at some point x at time t. So from this expression, can you tell me at what position of the bar the temperature will be maximum? Tell me. At what temperature? 40 centimeter. Very good. How 40? 40 centimeter. 40 centimeter means at the middle of the bar. You know, this much is 40 centimeter, middle of the bar. Because sine pi x by 80, if you want to make it maximum, sine pi x by 80, this will be maximum for x is equals to 40. If you put x is equals to 40, then this becomes sine pi by 2, that is 1, and the maximum value of sine is 1. So what is happening? The maximum temperature will be there at the middle of the bar. Now look at the question. How long will it take for the maximum temperature in the bar to drop 50 degrees centigrade? Means the temperature of the midpoint to fall down to 50 degrees. And you see the temperature is falling down with respect to exponentially. Okay. So the temperature at this point will decay exponentially. According to 100 e to the power minus 0.001785, see this formula. Now to find T when the maximum temperature reduces to 50 degrees centigrade, what you can do? We can, let's say it is let's say at time t the maximum temperature reduces to 50 degrees centigrade, so this will be 50, x equals to half, x equals to 40 centimeter, x equals to half because the total length is 80 centimeters, so x equals to 40, then x equals to 40 if you put, then only it will become pi by 2, right? Only, not x equals to half. So e to the power minus 0.001785 t is equals to half 0.5. That means your T is equals, we'll take logarithm on both sides. Okay, so ln 0.5 divided by minus 0.001785. So the value of the numerator is minus 0.63 divided by minus 0.0078. This will give you around 388 seconds, approximately 6.5 minutes. So you have, let's say, the maximum temperature at the mid of the bar. Now within 6.5 minutes, the temperature will fall down to 50 degrees centigrade. Okay. So you can see that if you put T equals to 0, and this is the maximum temperature at this point, so it is like initially 100 degrees centigrade was there. If you put T equals to 0, x equals to 40, means it is the initial temperature at the mid of the bar. So from this formula we are getting it 100 degree, 100 degrees centigrade. So from 100 degrees centigrade to 50 degrees centigrade, the amount of time taken to cool down from 100 degrees centigrade to 50 degrees centigrade is approximately 6.5 minutes. This is the meaning. Understood? Tell me. And this is because of this initial condition. Initially you maintained 100 sin pi x by 80 degree centigrade. Actually, if I talk about this, u of xt sum over n bn sin n pi x by l e to the power minus lambda n square into t, right? So n is equals to 1 to infinity. So as you take the values of n, as you increase the value of n, it represents the higher modes. So here we had sin pi x by l, so the first mode n equals to 1. If you are given n equals to 2, then it will become sin 2 pi x by, n equals to 3 sin 3 pi x by. Actually the overall solution is consisting of all the terms b1, b2, b3 up to infinity. Okay, so as you reach to higher terms, the falling of temperature will be quick. Let me give you a small part of this. Solve the same problem when the initial temperature is 100 sin 3 pi x by 80 degree. So what is different here? Here instead of n equals to 1, we have to take n equals to 3. Other data are as before. So how can you do this? We now have n is equals to 3 instead of n equals to 1. So what will you calculate? We calculated previously lambda, so only b3 will be there and lambda 3 will be there. Lambda 3 is equals to, you see, the formula of lambda n is equals to Cn by pi, or what was there, Cn pi by L. Okay, Cn pi by L. So in the lambda n square, it is like n square times c pi by L. So we have calculated this c pi by L is lambda 1 square, so n square lambda 1 square you can see. It is like 3 square times lambda 1 square. So lambda 1 we have already calculated 0.001785. So 3 square lambda 1 square will be 9 times 0.00178. So this will approximately give you 0.0160. Okay. So what will be the solution? B3 is now 100. Right? So your u of xt will become 100 sine, instead of pi x by 80, this will be 3 pi x by 80 e to the power minus lambda 3 square into t. So minus 0.01607 into. Okay. So here maximum temperature will drop in how many time? Look, for maximum temperature this term should be 0. Sorry, should be 1. For maximum temperature, it may not appear in the middle, it may appear at some other point. The maximum temperature may appear some other point, but you need to calculate the time it takes to reduce the maximum temperature to 50 degree centigrade. You see, here also the maximum temperature is 100, but here to reach from 100 degree centigrade to 50 degree centigrade, do you require same time or different time? So now you have to calculate 100 e to the power minus 0.01607 t equals to 50. So your t becomes ln 0.5 divided by minus 0.01607. So approximately you get 43 seconds. Okay, that is not important at which point we are getting the maximum temperature. The important thing is it asks you at how much time the maximum temperature reduces to. How long will it take for the maximum temperature in the bath to drop to 50 degrees? The maximum temperature for the first mode n equals to 1, it is appearing in the middle. For the third mode, it may not appear in the middle. It may appear some other point, but you have to calculate like how much time it takes to drop from 100 degrees centigrade to 50 degrees centigrade. You see, for the first mode n is equals to 1, it took around 6.5 minutes, around 388 second. Okay, we have got it 388 second, but here you see only 43 second, right? So this is almost 8 times faster. It is cooling faster, which is much faster than the previous one, than the previous mode. We can say 9 times as fast as the previous case. Okay, now the question is, why does it occurring 9 times faster? Why does it decay 9 times faster? Can anyone tell me? If it's sine 2n pi, it will be 0. Two n pi. How will you get 2n pi? You will get 2 pi x by 80. Yeah. So for even value of n, the even modes will not give you maximum temperature. only the odd values of n will give you the maximum temperature. If you took n equals to 0, n equals to 2, then that makes this part even, so sign will be 0. Yes, n is equals to 2, n equals to 4, n equals to 6. Those things are not contributing. Now the question is, why does it decay 9 times faster? The logic is obvious. You see, as you consider higher modes means the electrons are having more rapidly oscillating nature. If electrons are having more rapidly oscillating nature, so it will take less time to reduce the temperature. Okay, so you can just write it down. Why does it decay 9 times faster? This happens because the decay rate is proportional to n square. You see, this decay rate is primarily governed by this term, right? This is affecting the decay rate, and you can see it is having the dependence of minus lambda square. Lambda square is proportional to n square, so it is proportionally decaying in the form of n square. Decay rate is proportional to n square. So as you go for n equals to 1, you get n square equals to 1. You go for n equals to 3, n square is equals to 9. You go for n equals to 5, n square is equals to 20. So you can see it is rapidly increasing, 9 times larger than lambda 1 square, and that is why you get 9 times faster, right? The next mode you will get 25 times faster. Each higher mode corresponds to a more rapidly oscillating temperature distribution that dissipates heat more quickly. So it takes less time to reach from 100 degrees centigrade to 50 degree centigrade. For n equals to 1, it is taking around 388 seconds. For n equals to 3, it is only taking 44 seconds. Sorry, 43 seconds. Here, let me know once it is done. My laptop is not on charging, so if it suddenly stops, you will understand that the laptop battery has gone out. Okay, can you move forward from here? By today, this partial differential equation will be over. Then after, from the next day onwards, we'll be dealing with numerical analysis. Ajay, Harry, Muli, is it done? Quick, quick. Note it down quickly. look at this triangular initial temperature in a bar. Find the temperature in a laterally insulated bar of length L. Laterally means, okay, so this, if this is your bar, laterally insulated means like this. It is insulated and this, so that the heat can travel in this direction. Find the temperature in a laterally insulated bar of length L whose ends are kept at temperature 0, assuming that the initial temperature is given by this function. It is x between 0 to L by 2 and it is L minus x. L by 2 less than x less than L. So we calculated Bn, right? 2 by L root over, 2 by L integration 0 to L f of x sin n pi x by L dx, if you remember. So here f of x is varying in this way. It is varying between 0 to L by 2 as x, and between L by 2 to L is varying as L minus x. So we have to first calculate Bn, find the solution. Okay. So Bn is 2 by L 0 to L by 2 x sin n pi x by L dx and L minus x sin n pi x by L dx. Just check the theory part which we have done, and let me know if you are understanding this or not. So we need to calculate or evaluate these two integrals separately. First, let's evaluate the first integral, 0 to L by 2 x sin n pi x by L into dx. So we are going to use integration by parts. Integration by parts. Taking x as u, sin n pi x by L as v. So u integration v dx. So this is equals to u integration v. The integration of sine is minus cos, so minus cos n pi x by L into n pi by divided by n pi by L. So L by n pi. L by n pi cos n pi x by L limit 0 to L by 2 minus integration, differentiation of x is 1, integration of sine is L by n pi cos n pi x by L. Okay, one minus from the formula, another minus from the integration of sine, so they become plus 0 to L by 2. I hope this is clear. Are you getting this solution? Or any question? If you have any question, you can ask. So if you put L by 2, what do you get? This is equals to minus L by n pi into x is L by 2 cos n pi x by L. So n pi L by 2 by 2L. Okay, x is equals to L by 2, and if you put 0, x is equals to 0, so that is giving you 0. So the first part is evaluated. Let's go for the second part. So the integration of cos, another L by n pi will come, so it becomes L by n pi whole square sin n pi x by L, limit goes from 0 to L by 2. For x equals to 0, it is 0. For x equals to L by 2, it becomes n pi by 2. So this is equals to minus L square by twice n pi cos n pi by 2 plus L square by n square pi square sin n pi by 2. Okay, let's evaluate the second integration. L by 2 to L minus x sin n pi x by L times dx. So let's consider this as u, let's consider this as v once again. So again, minus L minus x L by n pi cos n pi x by L by 2 to L minus L by n pi L by 2 to L cos n pi x by L. You see here a one formula minus is there. Okay, one minus will come from the differentiation of L minus x, another minus will come from the integration of sine. So total 3 minus is coming, so that is why it is a minus. And if you put this value, if you put L equals to G, x equals to L, so the first term is not coming. If you put L equals to L by 2, it becomes L square by twice n pi minus sine is absorbed cos n pi by 2 minus L by n pi whole square sin n pi x by L by 2 L square by twice n pi cos n pi by 2 minus, you see if you put L x is equals to L, so it becomes sin n pi, so that is not contributing, but this is L square by n square pi square sin L by 2 n pi by 2. Now see the magic. Therefore your Bn becomes, you see, 2 by L into summation of this, integration, sum of this and this. So we have calculated both of them, so just put it here. So 2 by L, the first integration minus L square by twice n pi cos n pi by 2 plus L square by n square pi square sin n pi by 2 plus L square by twice n pi cos n pi by 2 plus L square by n square pi square sin n pi by. Okay, now you see this cos term is cancelling, minus L square by twice n pi cos n pi by 2 and plus this 2 term is cancelling, and these two term are same, so 2 times of this, so 2 into 2 4 and 1 L is cancelling, so this becomes equals to 4 L by n square pi square sin n pi by, a very good expression we are getting, 4L by n square pi square into sin n pi by. Now this value of Bn will be 0 if n is, if you put n is equals to, let's say 2, then sin pi, so that is 0, n equals to 4 sin 2 pi, that is 0, n equals to 6. Whenever you are choosing even value of n, the Vn value is 0. Now let's say if you choose n is equals to 1, look, it is actually following from this first quadrant, second quadrant, third, fourth. You remember in your class 11, if you have read it, the formula is wall sine tan, right? Do you remember this childhood formula? Your battery is running low. Okay guys, let's complete this problem quickly. All sine tan cos. If n is equals to 159 and so on, so you see it will come in the positive sign, first quadrant. So this is 4l by n square pi square. And if you choose n is equals to 3, 7, 11 and so on, this will become minus 4l by n square pi square. Okay, because at that time the sign value will be negative, and hence the solution is u of xt. So in the u of xt, what do you require? Sum over n equals to 1 to infinity bn sine n pi x by l exponential minus lambda n square into t, where lambda n is equals to g n pi by l. This was the solution, right? So b1 4l by pi square, let's say take common. So the n equals to 1 value is surviving. So sine pi x by l, an exponential, what will be there? Exponential lambda n square is equals to c pi by l whole square, right? Minus c pi by l whole square into n square. N square is 1. So this is the first term. Okay. For second term, you have to choose 3, n equals to 3. So this becomes, okay, is minus 1 by 9 sine 3 pi x by l exponential minus 3n pi, so 3c pi by l whole square into, okay, this will be the second term, and other terms will come like this. Do you understand this problem? So we are putting the values of n and we are getting the solution, and there is a curve to denote this. You see the figure shows that temperature decreases with increasing T because of the heat loss due to the cooling ends. So U is a function of x and T. Okay, so at any particular time it shows the temperature variation. So when temperature T equals to 0, if you consider that one end is kept at 0, another one is L is equals to pi, then you see when the temperature is 0, the variation you can see it is triangular. Okay, and at the midpoint the temperature is maximum, and as you increase the time it is falling down. T equals to 0.5, it is falling down. T equals to 2, falling down. So when you are measuring it after a long time,